Section 2.3 is about getting information from the graph of a function, okay? So we want to learn how to do a few things in this section. Do you want me to zoom in a little bit? No or yes? No? Okay. All right. So we want to learn how to analyze the graph of a function. Specifically, what we want to do is learn how to read the values of a function from a graph. We want to identify the domain and range from a graph. And we want to solve equations and inequalities graphically. Fogging glasses. Identify increasing and decreasing functions and determine local maximum and minimum values of a function. So the first thing to note is that the height of the graph is the value of the function. So we can read off the values of a function from its graph, okay? The domain is the set of all x values for which for which f is defined. So let me say that again. The domain is the set of all x values for which f is defined. The range of f is the set of all corresponding y values. So suppose we have this graph. We have y is equal to f of x here, and this is our function. And suppose we have the interval a to b here. This corresponding y value would be f of a, this point here. This point here would be f of b. That's the corresponding y value. So in other words, if you look at the height from here to here is f of a, right? So that's your y value. The height from here to here is f of b. So that's your y value there. So the x values between a and b, including a and b, these values represent your domain. The x values represent your domain. And the y values represent what? Your range. Very good. So you read your domain from your x-axis, and you'd read your range from what axis? The y. Very good. Very good. So now let's look at an example. Let's go through an example together. So page 2, I'm going to move this over just a little bit, and I'm going to zoom in a bit. Okay? So I've given you the graph of a function. Consider my drawing of the graph, okay? Take that into consideration, okay? The graph of a function g is given here. Find the following. Find g of -4, g of -2, g of 0, g of 2, and g of 4. That's the first part. B, find the domain and range of g. C, find the values of x for which g of x is equal to 3. And D, two more parts. D, estimate the values of x for which g of x is less than or equal to 0. And E, find the net change in g between x equals -1 and x equals 2. Okay? Now, this is a graph. The only thing missing from this graph is that this point here will be -2. Okay? All right. So, would you like to work on this together? Okay, so let's work on this together. Part A, I'm just going to write down what we need to find. We need to find g of -4, g of -2, g of 0, g of 2, and g of 4. Okay, so whenever we want to find g of -4, that means x is equal to what? What's x equal to here?
-4.
Very good. X is equal to -4. So we move over to -4 here. And then we need to find g of -4. So we need to find the corresponding y value. What is that? 3. So this here would be 3. Very good. G of negative 2, what's your x? Negative 2, so tell me what to do. 4. So we go to the left to negative 2, and then we do what? Go up or down? Up. And what do we have? 2. Good. G of 0, what's x? 0. And what do we do?
Go down.
Find 0, so we go down to negative 2. Good. G of 2, what's G of 2? 1. Very good. Why is it 1? That is correct, but why? So you find 2 on the x value, and then you go up. Why do you stop at this point instead of going to this one? Because this is a closed circle, which means this is included, and the open circle means that's not included. Very good. Yes.
If that top circle was filled in, would it be 2 and 3?
If-
1 and 3?
If the top were filled in, this would not be this would have to be connected.
Okay.
This would have to be connected. You can only have a closed and an open at the same point, or it can be closed together, which means the graph has to come in touch. Does that make sense? Okay. What other questions do you have? Make sure you're only working on what's in this class and not on any other sites. Okay. G of 4. G of 4.
0.
G of 4 is equal to 0. Good. G of 4 is equal to 0. Now we need to find our domain and our range. We need to find our domain and our range. Our domain we read from what values? X. Very good. What are the possible x values for this problem in interval notation? Absolutely. So the question was to repeat this one more time. So how do we write the domain in interval notation here? You just told me that we need to make sure we include, you want me to put a different color here to show you what we're doing? Okay, so where you said to include everything here, including those, how do we write that in interval notation? You can do it. What do we include? Yes, go ahead.
Is it close bracket,
Yeah.
-4, 4 close bracket?
Very good. Very good. That's right. And then, what do we do for our range? What values do we consider here? X values, Y values, what? Y values. Okay. For what Y values is this function defined?
-2 to 3.
-2 to 3, what goes around them? So you said -2 to 3. How do we write that in interval notation? What do you mean by open bracket? Parentheses or bracket? Bracket? Bracket, go ahead. Very good. Very good. Very good. What questions do you have? Okay, excellent. So we found our domain and range. Now in part C, we want to find the values of x for which g of x is equal to 3. What are the values of x for which g of x equals 3?
-4.
Negative 4, very good. G of negative 4 is equal to 3. So the x value for which g of x is equal to 3 is negative 4. Is negative 4. Do we have any others? Yes, no, you have to respond. Do we have any others? No, we do not. Very good. Because you may think that this would be included. You may think that g of 2 should be included. But remember, g of 2 is 1, not 3. Because that's an open circle. So it's not included there. Okay? All right. Good. Part D. Part D. Part D, we want to estimate the values of x for which g of x is less than or equal to 0. What are the values of x for which g of x is less than or equal to 0? 4, right? Because at 4 is actually equal to 0, right? So that's part of our answer. So 4 will be so x equals 4 will be part of our answer.
We also write it as G of 4.
No, you can just write 4. And in part C, you can just write negative 4.
Okay.
In part C, you can just write x equals negative 4 because I asked you for the x values. Does that make sense? Okay. So D, we have x equals 4 because we actually got 0 here, and it says less than or equal to 0. Where else is our function less than or equal to 0? G of 0. So 0 would be included in that. Is it just this? Where's your function negative?
Everything under 2.
Everything under 2? What do you mean by under?
Like everything, like left of 2, everything goes to. Actually, no, it goes from 2 to negative 2. It looks like everything's negative.
So this is negative 2, right here.
Yeah.
So this between negative 2 and 0 is what?
Negative.
Negative what?
Oh.
So are you saying right here?
Like everything in between 2 and like.
So initially you said everything between negative 2 and 2.
Yeah, that's.
But negative 2 has this part, which is positive,
Okay,
right?
Yeah.
That part is positive. Say this point is negative 1,
Oh yeah.
right?
Yep.
So would it be everything between negative 2 and 2? But the thing is, we want to know when our function is negative. Our function is positive right here. Our function is positive here. Our function is also positive here and positive here, except for here it's just 0.
Would be x equals 0.
That's only part of it. Yes?
Negative 1 to 2?
Negative 1 to 2.
Yeah.
This crosses a little bit before 2.
See from back here.
Exactly. It crosses a little bit.
I can't tell.
Oh, that's not zooming in.
Okay, well, yeah.
So, there you go. It's,
So like, I mean, the section that's underneath the x-axis is negative.
That's right.
But we can't tell exactly what it is because it's a drawing.
okay, so from right here to here is when it's negative, right?
It's like,
So we can estimate. That's why it says estimate. So let's do that. Alright, you have the picture? I'm gonna zoom back out. So that's here, about negative 1. And then here is a little bit before you actually get to 2. So let's say that's about 1.8, okay? So it's just an estimation, okay? Whenever you look at the problems in your homework set, you'll have actual unit marks where you can better approximate. Does that make sense? Let me zoom back out. Oh wow, get it together. Okay, it's a little crooked, but We'll make it work. Okay, so, x equals 4 and, why did I, oh, that was from 4. And we also have the set of all, or I'll use inequality notation and then switch to set notation. So we have between -1, all x values between -1 and 1.8. Okay, so in set notation, that means that we have the set of all x such that x is between -1 and 1.8, union the set that only has the element 4 in it. Okay, so that's what we will have here. What questions do you have? Yes? Part E. Find the net change in G between x equals -1 and x equals 2. How do we find the net change? We talked about that before. But in here we have G. So how would we do that if I want you to find the net change in G between x equals -1 and x equals 2? Talk loud. And online, you can unmute your mic if you want to answer. Not everybody at once. We would have G of B minus G of A. What did I give you? Did I give you all of G of B or did I give you B? Or did I give you A? What did I give you? I'm saying find the net change in G between x equals -1 and x equals 2. Yes.
G is A.
What's A?
The
What's A?
Is that X?
What x? I gave you 2 x values.
A would be -1.
A would be -1, good, and what's B?
2.
2, good. So that would be equal to, very good. So that's equal to G of 2 minus G of -1. What is G of 2? We found that out in A. 1 minus, what's G of -1? You have to look back at your graph. 0, good. So you get 1. That's your answer. Make sure you are working through your homework. Now you have a lot of sections you should actually work the problems for over the weekend or before the weekend. Okay? Any questions here? Okay. The solution or solutions, I'm going to move this over a little bit. The solution or solutions of the equation f of x equals g of x are the values of x where the graphs of f and g intersect. The solution or solutions of the inequality f of x strictly less than g of x are the values of x where the graph of g is higher than the graph of f. So to illustrate these two definitions, consider the first graph. Notice that I've drawn here the graph of g and the graph of f. They intersect where? At what x values do they intersect? A and B. So the solutions of this equation, f of x equals g of x, going back to this definition, are the values A and B. A and B. To illustrate the second definition, Notice that I've given you the graph of G, the graph of F. Now, it says the solutions of the inequality, f of x strictly less than g of x, are the values of x where the graph of G is higher than the graph of F. For what x values is the graph of G higher than the graph of F? Interval notation. Go ahead. Is it just, so if it's just A is less than B, how do we write that in interval notation? Are you including A and B? I see heads shaking no. I need you to talk, remember? No? Okay. So you said A is less than B, so we'd be talking about to the left of B, but do we go past A like that? No, where do we stop? We stop at A. So we should have from here to here. How do we, but you just said not including A and B. How do we write that in interval notation? Good, parentheses A, comma, B. Very good. Okay? So now what we're going to do is go through example 2. And in example 2, we're actually going to solve the given equation or inequality graphically. And you'll see problems like this in your homework set. Okay? So, I gave you the equality or the equation negative x squared equals 3 minus 4x. And B, I give you the inequality negative x squared is greater than or equal to 3 minus 4x. A hint here is to first move all the terms to one side of the equation and then graph the function that will correspond to the non-zero side of the equation. That's one thing you can do. Alternatively, you can set up a chart or a table and find your values that correspond. Find your corresponding y values. So let me move this up. So you'll have x, negative x squared, and 3 minus 4x. Those are your functions involved. Your input values are your x values. These are your inputs here. Okay? So we'll choose values of x, find out what these values are, and then we'll plot them. So we'll say x is negative 1, negative 2, 0, 1, 2, and 3. That should give us a good picture. So when x is negative 1, what is negative times negative 1 squared? No, it's not 1. Write it out. Write it out. It's negative times negative 1 squared. You have to make sure you follow your order of operations. Put it in parentheses. Negative 1. When x is negative 2, what do you get for negative x squared? Negative 4. Good. 0. 1. There are a lot of you in here, and some of you aren't talking. Remember, I give participation each week. Negative 1. 2. 3. Negative 9. Good. When x is negative 1. Oh, you had a question. Go ahead.
Yeah. So when you have something like this.
So let's finish filling out our table. So when x is negative 1, what do we get here for 3 minus 4 times negative 1? 7. Good. What do we get when x is negative 2? 11. Good. 0. 3. 1. Negative 1. 2. Good. And negative 9, not negative 9, 3. Negative 9. Good. Giving it away. Okay? So, that's what we have. So now let's plot some points. We'll plot all of the points that we have. So we'll first graph negative x squared. Okay? So when you have negative 1 here, when x is negative 1, We found out our corresponding y was -1. So we'll have -1, -1. Then you have -2, -4. Then we had 0, 0. What's our next point? 1, -1. Good. What's our next one?
2, -4.
Good. 2, -4. And then we had what? 3, -9. Okay, so sketching that graph, this is a sketch. We have this. Okay, that will give us -x². And now let's graph 3 minus 4x. Plot those points. So one point was -1, 7. So -1, let's say that's 7. The other one was -2, 11, so somewhere up there. What was another one?
0,
No, 0, 0 was on the graph of -x². So now we're choosing these as our y values. So when x is 0 for 3 minus 4x, what do we get? 3, good. So let's say that's there. Continue. -1, -1, you said?
Yeah.
Not -1, -1. We're not choosing, remember, this section here is -x². We're looking at the x values and corresponding y values.
They're
1 and -1. So we already have that marked there. And then, what do we have? 2 and -5. Good, let's say that's there. And then what else we have? 3, -9. Good. Notice that we can now sketch our graph. This is a line. This should look like a line. Let's see. I'm gonna do some exaggerating. The sketch is not the best, but let's make sure it kind of looks like what we're supposed to have. Okay, so we have our line. Where do these two intersect? Part A says find out where -x² is equal to 3 minus 4x. Where do they intersect? No, they don't intersect at 1. At 1, -1? Is that what you said? Okay, so when 1, -1, those two graphs intersect. So the x value where they intersect is what? 1. Good. So for part A, -x² equals 3 minus 4x when x is equal to 1. Do we have another x value?
3.
Good. Or x equals 3. Good. Part B. -x² is greater than or equal to 3 minus 4x. When do we have -x² is greater than or equal to 3 minus 4x? For what part of the graph do we have that?
The x value, no, the x, one and three, the x value is one and three again.
Only 1 and 3?
And two,
And 2?
yeah.
So so you're saying only at 1, 1, 2, and 3? So what happens to the rest of the graph? You're saying only pick this point, and this point. Is that what you mean?
And the points in between.
Oh, right. So everything in between.
Yep.
In order to indicate everything in between, you have to tell me what the inequality would be. Whenever you name specific whole integers, you're only giving me part of it.
Yeah.
Does that make sense?
Yeah.
Okay, so how would we write that? As an inequality or an interval notation, whichever one. There are a lot of you in here. Go ahead.
1 inclusive, comma 3 inclusive.
Bracket or parentheses?
Bracket.
Good.
So bracket.
Very good. So bracket 1, comma 3. Bracket. Very good. Okay, so when x is between 1 and 3. Good. Very good. What questions do you have? Okay. Now what we're going to do is we're going to solve the given equation or inequality algebraically. So we're going to take the same example that we worked on previously, and we're going to solve it algebraically so you can see the other way to approach this problem. Okay? So for part A, what you would do is you can move the, let me erase that. You can move the negative x squared to the right, and that would give you 0 equals 3 minus 4x plus x squared. Or rearranging our terms, we'll get 0 is equal to x squared minus 4x plus 3. And then you can factor this. How? Go ahead.
X minus 3, x minus 1.
Good. So that means x minus 3 equals 0, or you have x minus 1 equals 0. This means x equals what?
3 and 1.
X equals 3, and x equals 1. And you will see from the previous example, this corresponds to our answer. Which method do you like better? This one? This section is all about graphing, so whenever you see this done in your book, they're going to ask you for the graphical method, but this is a way you can go back and check to see if you have the correct thing. Yes?
So like if we were taking a quiz.
For part B, we want to solve the inequality negative x squared is greater than or equal to 3 minus 4x. And this is a similar way. You have here, right? You have 0 for part B. You would have 0 is greater than or equal to 3 minus 4x plus x squared. Or we can rewrite this and say x squared minus 4x plus 3 is less than or equal to 0. And the way a lot of people do this inequality at this point, they factor it like we did before, and they set it equal to 0, but they keep in mind that we really need less than or equal to 0. And then what they do is find the zeros, like we did before. So we found out that x would equal 3, or x equals 1, right? Are you with me? And then set up a number line. You have 1 here, and then you have 3 here. Now, because this is less than or equal to, do we include 1 and 3? Yes. Why do we? What part of this do we take care of when we say yes? The equal to. Very good. So we definitely include 1, and we definitely include 3. Okay? Now what we do is we've broken our number line up into how many parts? How many parts of this do we have? I hear 2, I hear 3. How many segments do you see here? 3. 1 here, 1 here, and 1 here, right? So we have to check numbers to the left of 1 to see if we get something that's less than 0. Here, see if we get something less than 0, and here to see if we get something less than 0. If we do, that means we include that interval. If not, we do not. Does that make sense? Okay, so now let's check. So to the left of 1, what value do you want to choose?
0.
0, okay, so we will check x equal to 0. When x equals 0, we get, you do not have to use that symbol, that implies. When x equals 0, we get in our equation, what? So we're checking it in this. When x equals 0, what do you get? 3. Is 3 less than 0? Yes, no? No. So that means we don't include that part. Now, what do you want to check between 1 and 3? Check x equals 2. Then that'll give you 3 minus 4 times 2 plus 2 squared, which is 4. What do we get? -1. Does that satisfy the inequality? I hear no, I hear yeah.
No. Yes.
Why yes?
Because -1 is less than 0.
Absolutely, because -1 is less than 0. So -1 is less than 0, so yes, we include that interval because it's satisfied less than 0. Very good. Now, for the right of 3, what value do you want to check? 4. So check x equals 4. And then you get 3 minus 4 times 4, bless you, plus 16. What do you get here? Talk loud. What do you get? 3. Is that less than 0? No. So do we include this interval? No. So what interval do we have for your answer? Not -1.
1, 3.
Tell me how to write it.
Oh, sorry. Bracket 1, comma 3 bracket.
Good. Which is exactly what we got before.
You said -1 is, you can use that because why?
No, we don't use -1 because it's y. What happened was, what we're doing is we're checking x values in the interval to see if we get something that satisfies this inequality. So the equation we're checking to see if we have satisfied is x squared minus 4x plus 3 less than or equal to 0. And then whenever we checked x equals 2, we got the value -1. -1 is in fact less than 0. So that means whenever we check any value between 1 and 3, that's going to satisfy this inequality. So that means we want to include all of the numbers between 1 and 3, including 1 and 3, because 1 and 3 make this inequality 0. Does that make sense?
Yes.
Okay. What other questions do you have? Yes?
Can we do another example of this?
We won't do another example of this in here because what this section is going to do is ask you to do it graphically.
Oh, okay.
So it's looking for the other method. But whenever you're working through your homework questions, you can absolutely try this method and ask me if you have questions. I'll be happy to answer them. Okay? What other questions do you have? Okay, all right. So another concept that we're going to talk about is that of an increasing and decreasing function. So f is increasing on an interval I It's increasing on an interval I if f of x1 is less than f of x2, whenever x1 is less than x2 in I. So to put this definition into a graph, what this says, let's look at the first part. So if you're visual, pay attention. Here, we have x1 is less than x2, right? It's to the left of it, so x1 is less than x2. Now, this corresponding point here is f of x1, this is f of x2. Notice that f of x1 is less than f of x2, right? It comes here and then here. So you would have this is f of x1, and that's f of x2. Notice that f of x1 is less than f of x2, which means your function is increasing. Okay? Now, f is what we say decreasing on an interval I if f of x1 is greater than f of x2 whenever x1 is less than x2. So still we have x1 is less than x2. That is the case. But notice here, f of x1 is higher up, right? And f of x2 is here. So notice that f of x1 is greater than f of x2, which means f is doing what here? Decreasing. Good. Okay. What questions do you have? Okay, so in the next example, we're going to apply a lot of the information we've learned. So we want to use the graph to determine the following. We want to find the domain, and all of our answers should be in interval notation. Use the graph to determine the domain, the range, the intervals on which the function is increasing, and the intervals on which the function is decreasing. Would you like a couple minutes to try it? Okay. All right, let's go over this problem. What is our domain for this given graph? In the back.
Parentheses, negative infinity, comma, infinity, parentheses.
Very good. How do you know it's negative infinity to infinity?
Well, because of the arrows, they're like kind of going both left and right.
Very good, because of these arrows, keep going. Very good. B, what's the range? Okay.
It'll be close parentheses.
Or close bracket?
Yeah, close bracket, 6 comma infinity, open parentheses.
Does everybody agree?
Negative, is it negative infinity?
I'm asking.
It's negative infinity.
So if you're saying negative infinity, my question is then, how do you write it?
Negative infinity, you switch the two.
So now you're saying it's not this. Tell me how to write it.
Parentheses, negative infinity, comma 6.
Parentheses, negative infinity, comma 6.
Bracket.
Does everyone agree?
Yes.
Yes. Good. Good. C. What are the intervals on which the function is increasing? Go ahead. Okay. Open, so bracket. You can just say bracket. Go ahead. Does everyone agree?
No.
No? Who wants to share what they got? Go ahead.
Bracket, -5, 0, bracket.
-5, 0, bracket.
Yeah, he's right. It would be 0.
So right now we are questioning this one and this one. Any others?
The second row, because after the 0, everything
You have someone else? Go ahead.
I'm not sure if this is right, but it's, parentheses, negative infinity, comma, 6 bracket, like, it's this, yeah,
Okay.
I
Go.
have that, but instead of a bracket, it's parentheses, comma 6. So it's parentheses negative infinity, comma 6 parentheses.
Comma 6 parentheses. Any others? So remember, our function, right now we're questioning whether where our function is increasing. You have a question?
I had another possible answer.
Okay, so you want to change what you had. Go ahead.
Bracket negative infinity.
Can you have a bracket at negative infinity?
Parentheses.
Go ahead.
And comma 0.
Okay, so now we're questioning there. Okay, so now remember from the previous page we said our function was increasing if our function looked like this, right? Okay, if whenever we have x1 is less than x2, then f of x1 is less than f of x2. Well, this function is always increasing. It starts increasing and then it increases until it gets right here. The x values that correspond to this would be negative infinity to what?
6.
The x values, not the y. Negative infinity to x equals what?
0.
0. You have to remember, you're reading your x values whenever you're looking for the intervals on which the function is increasing or decreasing. You're looking for your x values. So the correct answer out of our choices is this one. Negative infinity to 0. Now, what would be the interval for which our function is decreasing? Yes.
0, comma infinity.
What goes at 0?
I'm sorry.
What goes at 0?
Parentheses.
Parentheses. 0 to infinity.
Parentheses.
Parentheses. Good. And we don't include 0 because at 0 the function is neither increasing or decreasing. Right? That's why we have parentheses there. What questions do you have? Okay? Good. The function value f of a, is what we call let me zoom in and move this down. That is a local maximum value. Can you read my writing?
Yes.
Okay. The function value, f of a, is a local maximum value of f if f of a is greater than or equal to f of x when x is near a. This means that f of a is greater than or equal to f of x for all x in some open interval containing a. In this case, we say that f has a local maximum at x equals a. So pay attention to the notation or pay attention to the phrasing. A local maximum value is the corresponding y value. Where your local maximum occurs is the x value. Okay? So make sure you know the difference. So if we look at this graph below, here, this is our function. Notice that this point is a local maximum value. This point here is also a local maximum value. So this is a point rather. So these are local maximum points. or their local maximum values. Okay? Now, the other definition, the function value f of a is a local minimum value of f if f of a is less than or equal to f of x when x is near a. This means that f of a is less than or equal to f of x for all x in some open interval containing a. In this case, we say that f has a local minimum at x equals a. So in our graph, notice that we have a local minimum here and a local minimum here. So those are the local minimum values. Points or values. Okay? So now let's apply this to an example. The graph of a function f is given. Use the graph to find the following. A, find all the local maximum and minimum values. So find the corresponding y values of the function and the value of x at which each occurs. So I'm asking you to find the local maximum and minimum values and to tell me where they occur. Okay? So let's go through that. Part A. We have a local maximum value of what?
-2, 3.
What is the value?
3.
The local maximum value is 3 at x equals what?
-2.
X equals -2. Good. Very good. Do we have another one?
Yes.
Yes. Good. And where at? What is your value?
2.
2 at
1. X equals 1.
at x equals 1. Good. Do we have any more?
No.
No. Very good. Now, what about our local minimum values and where they occur? What's the value? 0 at
-1.
x equals -1. Good. Do we have another one?
Yes.
Where at?
-1.
-1. So that's our value. And where does it occur?
At x equals 2.
At x equals 2. Good. Do we have any more?
No.
No. Very good. That's it. Now, the question in part B says, find the intervals on which the function is increasing and on which the function is decreasing. Find the intervals on which the function is increasing and on which the function is decreasing. Would you like a couple minutes to try it? I'll give you a couple minutes to try it. So, what are the intervals where your function is increasing? Go ahead. Oh, over here. Let's go over here.
Parentheses, increasing, sorry, parentheses, -infinity to -2. You want me to keep going?
Yeah, you can keep going.
Uh,
Was that a parentheses there?
Yes.
Okay.
Parentheses, -1, comma 1, parentheses, and parentheses 2, comma infinity, parentheses.
Good. Very good. That's where our function is increasing. Okay. Where is it decreasing? Go ahead.
-2, comma parentheses, -2, comma -1.
Mm-hmm.
And then parentheses, 1, comma 2.
Very good.
You need to include the union.
Say it again.
You need to include the union.
You can say union or you can put and.
Okay.
Either one is sufficient. Yes?
For decreasing, what about negative, parentheses, negative infinity, comma, 0?
Negative infinity, comma, 0. Oh, no, because here, if we go from negative infinity to 0 for x, notice that your function is increasing from here to here, but it's only decreasing from here to here. So remember, whenever you're looking for decreasing, you have to find the x values for which your function is decreasing. Does that make sense? Okay. What other questions do you have? Okay, so that is section 2.3.